Good morning to after break. Anyways, this is April 12th. Is that right? April 12th? All right, get started here. We're hopefully going to finish up 6.1 today, finally. And so hopefully you had a good break as well. And let's get started. So welcome to April 12th, the day after break. Oof. Okay, we had some fun stories to share. And then let's get started here. 6.1, we're just learning how to solve equations. And that's primarily, if you guys think about it, when you guys get to calculus or any other thing, solving equations is primarily what we do. You know, when you solve for x, when you do factoring. So this is part of the piece, probably the most important chapter if you're going to go on in mathematics here. So got to solve equations here. So with that started, let's jam. Just review. I know it's been a long time. It's been like a very long time. So let's go with it here. What we want to cover is just simple equations, factoring. Then we have to use the quadratic formula. And then we're going to use something called horizontal translation. So these are the basic ones that we get started with here. I should go this real quick here. Sorry. Let me jump to this one. Let me show you. There it is. Yeah, let's do this one together. There it is. Okay, so homework sheet. There's only 4 sections here, so we should be able to cover it kind of quickly here. Oh, it's the dread for some others. Okay, so let's go with it. 1 through 45 is the homework sheet. This is the honor section right here. You can read that. I delineated even the numbers just in case. And then some people have chosen to do all the odd problems for some reason. I'm not sure why, but yeah. But they'll not be given extra credit. So let's go with it. 6.1, basic stuff. 6.2, more cool and awesome equations to solve. And then 6.3, we have something called multiple angles to solve. And that's it. Those kind of like the basic fundamentals there. And then something called parametric equations. Each author, when they write a textbook on Trig, they have to stick it somewhere. So your author decided to stick it at the end of chapter 6. We're good. It's just one section. It's a new little kind of thing to think about. And it's different how we think about equations. They're called parametric equations. Yeah. Okay, anyways, we good there? Grade your own homework before turning it in. I do need evidence of the fact that you have graded it. And then if you can, if it's a major fix, then there's usually a correction page at the after the homework. So you guys put that, that's cool. If it's a minor thing, I see you kind of put in the margins, that's cool too. Be good. But somewhere we're grading it here. All right, I think that's it. So let's jam down to this right here. So quick little thing here from algebra. Addition property, multiplication property still holds. This is cool. I can add the same number to both sides, and I can still keep an equal sign. I can multiply the same number both sides as long as it's not 0. I can still keep the equal signs. And then we started with our little basic equation right here from algebra. That's too simple. True? No, just waiting to see if you guys have woken up yet. Nope. Okay. And we have factoring. Factoring, how we do that is that right there. And you guys learned it like this little box method, huh? Because I've been looking at the algebra book now, like, oh, you guys learned it a different way. Gotcha. Okay. And this is called the Xbox method. I like that. Then there's the Xbox 360 method, but I won't show you that today. Jamming with the other ones there, quadratic formula. There it is. Boom. Putting that in. And if you need to write it down, that's cool. And then we have this little piece right here that you can't read. So I'll go like this. All the different entities we've covered so far. Not supposed to read them because you're not supposed to write them down either.
Wait,
but
we're not supposed to read them?
Wait, we're not supposed to write?
Sorry, you should only look at them.
You're not supposed to read or write.
Do not look at this slide.
Do not read this slide. Yeah. Trigonometric identities, all the stuff we've covered so far will be in use during this chapter. We get because chapter 5 really was just to get us to chapter 6. That's kind of it right there. All right, let's keep on going. And then we started off with basic equations here. Do you guys remember these guys or no?
No.
Do we need to go over them or no? Talk to me.
Sure.
We should go over like.
I do remember what theta is.
Yeah. let's do maybe like the first one, just to get us.
Oh, it's dark. Wait.
Oh, so weird.
It's all gone. Okay, let's do this one. And I think we'll be okay like that. And then we'll answer the homework. So we'll do this one. We'll do 4. We'll jump to 8. Because that'll refresh our memory here. And then we can do this one over again as well. No?
I don't think we've done that.
This
Oh, wait,
was,
yes, we have.
yeah, we did it on, because it's the factoring portion here. We probably should do that one here. Okay, so I'm going to cut this one out as well. So let's jam. I'm going to go back to number 4, redo that one real quickly here, then we'll keep on going. Why is this is so small? Let me do a little something real quickly here. Let's jam with it. So example number 6, find all the degree solutions and then find just from 0 to 360. And the basic one, let's jam. You guys probably written down already here. So if you want to write it down still again, that's fine. If you just want to look, we can do that too here. Ask questions as we go. So we're just trying to at least solve for the trig function itself. We have cosine theta is equal to 1/2. And for these, especially when you do the calculator portion, you got to be very, very careful when you do that. Or just careful, not very careful. For these, we can, if it's a value we know already from a unit circle, you could just look on the unit circle. Good. All right, so I'm thinking this right here. Think back to my unit circle. When does cosine give me a 1/2? Thinking it's probably like right here, 30 degrees, is that right? I think so.
Mine says 60.
Or 60 degrees. Let's change trigonometry today, right? 60 degrees. Right there. I'll give you the 1/2. On a unit circle, you're just looking for this right here, right? You're looking for when the x value is 1/2. You look down over here as well in quadrant 4, you should get another one. Then that probably should be 300. And as I said in lecture notes, it's almost easier to do B first and then do A. So let's do it that way here. So B, the two answers are 60 degrees and 300 degrees. Done. I found the angle value that makes that true. And then what happens for A, I have to find all of them forever and ever and into infinity. So the way we do that, we just say 60 degrees plus 360 degrees K. And you can define K over here if you like. And then 300 plus 360 degrees K. And you say K is an integer. Are we good, guys? Cool.
Wait, so why do you only put K as an integer for the bottom one?
You can do it for the top.
Oh.
Yeah, you can do it for the top as well. Just so you can just write it once if you need be, because you're saying K is the same for both of them.
Okay.
Okay, are we good there? Okay, this one we did not do last time. Boom. Number 8, I think. Yeah, we didn't do number 8, so let's start off here. Lecture. We did 8
No,
for
but it
sure.
wasn't that.
Oh, that's right, yeah, because this is the, I changed up 8 on you guys, huh? Can we do this here? Can we do this as the new 8? Kind of like. See, 1 second, let me just check something out real quickly here. Seven, 8, and 9. This was, if you guys want to relabel yours, just real quickly here, so we have the same. This is what we did for 8 last time, is that right? If you want to relabel that as 9, we'll do that one next. We'll kind of redo that one again. Relabel that as 9 because I missed it and then I really needed to do it anyways here. So let's jam. Here it goes. Boom, sine theta minus 4 is equal to negative 2 sine theta. Oh man, just like x's in algebra, we have to move all the x's to one side. And you guys talk to me here. Which way should we go? What should we do to get sine theta by itself on one side? I could sing Jeopardy. Dun, 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 dun. Dun, dun, dun. Sorry, here. Go ahead, Grant.
And you can add 4.
Add 4 to both sides. That would work as well. I do want to.
Could you just add 2?
Yeah, kind of 2 different ways to do it. You can subtract sine theta and just move it over here, right? Except sine theta is going to be on your right-hand side. We usually don't like that. Uh-huh. And then you have to divide through by a negative as well afterwards. But usually we want to do this here. We're good. Are we good with that? We want to get the sine or the trig function on left-hand side. That gives us 3 sine theta with a funny little symbol equal to 0. That's okay. And eventually, as Grant said, move the 4 over. So get a trig function together first, then move everything that does not have the trig function to the other side. Do some algebra, and we are almost done. Sine theta is equal to 4/3. Okay, is that a value that we know? No, I don't think that's on the unit circle, right? Unit circle is 0, 1, 1/2, square root 2 over 2, square root 3 over 2. Oh, cool. Okay, Adrian noticed something. You got a sine value that's going to be 4/3, which is more than 1. That's not possible. In fact, even if you try it on your calculator, if you want to try it on your calculator here, let's go like this. Theta is equal to sine inverse or 4 over 3. Punch that into a calculator, and it's going to say error to you, right? Something's wrong. You can't have a sine value that's greater than 1, so therefore we have this little guy. It goes like this and like that. No solution. So symbol for no solution, or you can just write it out. So this one does not have a value at all. Are we good?
So this whole equation just doesn't have.
Doesn't add up.
Just like a fat 0 line through it.
Fat 0 with this. Have you guys seen that before? The 0 with the slash through it for no solution? No.
Isn't that just 0 or is it special?
It has a line through it, idiot.
Okay, but when I was in 3rd grade, my 3rd grade teacher wrote it with a slash through it.
Oh yes,
Do that, like on phones where
Yeah.
like they, it's like a
Oh,
big
yeah.
one with
Yeah,
pictures.
some people are wrong.
Am I the dumb person?
Yes.
And then also in the military, whenever they're doing accounting, because I have a friend that's in the accounting military, and they do put a slash through it for all the zeros, they put a slash through it to make sure
To
that.
differentiate
really,
it
I'm
from,
just
from
wrong.
L,
Yes,
so
correct.
that it's easy to tell.
So there's that.
Good zeros.
My bad.
Okay, so number 8, no solution with a funny symbol behind it. Okay. This one we did last time here. So now let's get into factoring here. So factoring, then we got to move to quadratic formula eventually. So let's jam. This one, notice it said equal to 0. That's great. The only problem is you have 2 different trig functions. That's no fun. If you have 2 different trig functions, you got to get them out separate from each other because you got to solve for each trig function here. So we already did this one already here. Let me do it real quickly here. Cosine of x gets factored out. And if the whole thing gets factored out, we're still left with the 1, yes? I know, still too early and right after break. Okay, are we good there? We got 2 things that are multiplying each other to give you 0. Therefore, I can set each of them equal to 0. And you might have to still You might have to still solve. Yeah, let's go with it. Cosine of x. When is cosine of x equals 0? Chart. Give me those guys.
Pi over 2 and 3 pi over.
Awesome. Pi over 2. 3 pi over 2. Perfect. Okay. So let's go to the next one here and we'll put it all together here. So I'm going to subtract 1 from both sides. Divide by -2. Oh, not 22. Sine of x is equal to a positive 1/2. Okay. Chart again. Give me some. Oh, hold on real quick here. Oh, yeah, that's right. We're in radian. I just want to make sure we're in radians. Okay. In radian form, when does sine give you a 1/2?
Pi over 6 and 5.
Thank you so much. Pi over 6 and 5 pi over 6. Okay, I think we're ready for some answers here. So doing B first because it's easier. I have pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6. You'll notice in the back of the book that all of them, they're always in order. They go from the smallest to the largest. Don't have to be in order as long as you list all of them. We're good? Okay, part A. Let's jam with it here. So this is in radian measurement. So pi over 6 plus 2 pi k. That's one answer. 5 pi over 6 plus 2 pi k. That's another answer. And then this one. Notice that these two here are exactly 180 degrees away from each other. They're exactly pi away from each other. So this one, just to be super cool, you can write it like this. You can say, hey, you know what? It's only half a rotation around each time, right? If you put pi over 2 plus 2 pi k and then 3 pi over 2 plus 2 pi k, that's still correct. We good? That's still no problem. But if you put pi over 2 plus pi k, that takes care of both of them at the same time. That's cool. And then we got to designate what in the world is k. K is an integer. We good? With no one write anything down because we already wrote it down earlier. Okay. Cool. Okay. Jam, next one.
So if it's 180 degrees away from the other one, you can just write pi.
This pi is 180 degrees. That will happen usually for you guys with tangent. Because tangent and cotangent, their answers are always 180 degrees away from each other. So you guys will see that in the homework. Okay, now, now the fun stuff here. Maybe factoring, maybe quadratic formula, we'll see. Also, it does say use a calculator and round to the nearest 1/10 of a degree. Ooh. Okay, see how that ends up. Let's go with it. Did we do this one or no? No, okay. Interesting. All right. On top, it does give it away here. It says the quadratic formula to solve the equation here. Some of these, as my trig teacher used to teach me here, so you can convert this into algebra and just sort of see if it factors. We're good? If you convert this back into 2x squared plus 2x minus 1 equals 0. I'm just using x as my variable. Would that be something that you would like to factor down, yes or no? That's not easily factorable. I mean, I could try a few things here. I can try 2x times x. I could try 1 here, plus 1 minus 1, I guess. That does not work nicely. If this is a 1 or a 3, it would have been working fine. So not factorable. Are we good? Or at least not easily factorable. Okay, because of that, we have ourselves, the formula works all the time. So it's going to be cosine theta is equal to whatever we get from here. Let me change pins. Let's see if this pin works better. Boom. What do you guys say? This is A, that's B, and that's C. And if you need to look up the quadratic formula, please look it up. I think it's called negative B plus or minus the square root of B squared. It still does the little funny things. Minus 4AC all over 2 times A. You guys talk to me. Did we do this one or no? Before break. Okay.
We did any with quadratics.
No quadratics. Okay. Yeah, we just did the factoring one, right? That's all we had time for. Okay, let's jam. So the stuff inside here, I just like to do that separate so I'm not rewriting the problem over and over and over again. So I got myself, looks like 4 plus 8, is that right? 2 times 4 is 8, times a negative 1 is a negative with a negative in front. I'm gonna go with 8, we're good?
Actually, this one as example
Talk to me.
3 and like written down, like I have all the work written out. Like I think we did do it.
I remember
have it
something
with
like that.
X's instead of cosines.
Okay, got it. So we just did this little piece right here. Is that right?
Oh yeah, I have that. I have that too. Yeah.
Yeah, we just did that.
Okay. Gotcha. Okay, so we'll redo it here and then we'll do another one. Yeah, because I remember factoring out the 2 and reducing the 2, something like that. Okay, let's keep on going. We'll finish it up. Did you 12 square root of 12? 4 times 3. 4 is a perfect square. And so how about a 2 gets to go out, a 3 gets to stay inside, and we get ourselves negative 2 plus or minus 2 root 3 over 4. All right, and hopefully from algebra or algebra 2, you guys learned the little trick. Mathematically properly, you'd have to factor out the 2 first and then reduce it with the 4. Or you can just say, you know what, what's the number that goes into that number, and that number? And so I can divide each of those guys by 2, and I can reduce that down to a negative 1 plus or minus the square root of 3 over 2. All right, and I need more room. What's the time? I think we're done time. Okay, let me add an extra slide here. Okay, Jamming. Let's split it up now. So cosine theta is equal to a negative 1 plus root 3 over 2. How about a cosine theta is equal to a negative 1 minus root 3 over 2? And Georgia, did we finish off the problem itself? Did we finish it completely with the calculator and everything? We did, right? I think so. No.
I just have the negative 1 plus minus square root 3.
Okay, gotcha. So we got to this point.
Yeah.
Okay. Okay, this one is going to involve a calculator, so we got to be mindful here. If you have a calculator, you might as well take it out as well, just so we can put this together. So this guy is not on a unit circle. That's no fun. Second of all is we also know that in cosine, for cosine particularly, cosine is positive here, negative here, and positive here. True. Okay, so let's keep that in mind as well. All right, so real quick here, we are going to do this here. Cosine inverse of negative 1. Hold on real quick here. Sorry, before we do that. Can you guys punch this in the calculator here? Negative 1 plus root 3 divided by 2. Let's see what the answer is to that first. This would be a little bit long one here for us to finish up here.
I got 0.366.
Okay, so it's
But
positive.
someone should
Good.
probably check that.
0.3. So it is approximately 0.366 about. Tell me if you got something different and tell me if you,
Yeah, I got the same thing.
same thing. And you guys do need the parentheses for the top, is that right? Just to make sure it all set together. Okay, Grant, we good?
366.
Cool.
Yep.
Perfect. And Haley, how are you doing? Good? Okay, awesome. Okay, because it's positive, that's great. So what we're gonna do is we're gonna say theta hat, I like hats, cosine inverse of -1 plus √3 over 2. So you can do one of two ways in the calculator here. Let me get off the screen here. Save, let's go here. Slow computer. Yeah, okay. Boom. Radian measurement, or what measurement are we in? Degree measurement. Okay, so first things first, let's get our calculator in degree measurement to make sure we got. Mode. I'm in radians, back to degrees, ding, ding, ding. And I'm gonna try just real quickly here. -1 plus the square root of 3. Just making sure that you're correct. Divide by 2? Yes, all right. Okay. If you punch this in already here, what we could do is you could go cosine inverse. And you could just punch in the answer. Here's your A and S right over here. It's an answer from your previous answer goes in. And with that, you click on it and voila, love it. Now this angle should be in quadrant 1.
Why is it? It says there's a dome in there.
Okay, let me check.
Oh,
Okay, everybody, okay there. Grant, you good there? Calculators, okay. All right, are we okay with 68.5? Okay, I see shaking of heads. Okay, this is good. So theta hat is 68.5. So that means I just got the one that is in quadrant 1. There's my 68.5. But I also know that cosine is positive in quadrant 4. So I also have to get this one. Talk to me, guys. How do I get that one? I'm in quadrant 4. Almost have a full rotation. I have 360 degrees.
is it 360?
Yeah, I go with that, yep. So in quadrant 4, it's 360 minus 68.5, whatever that's gonna be. So now you gotta punch in the calculator. Can you help me out? What is 360 minus 68.5?
291.
291, I assume 0.5, because I can subtract 5 from 10. Cool. There are my angle measurements. So now I go to here. I say theta is equal to, oh, this is B, right? Hold on, sorry. Not too fast, not too fast. Let's set those up as answers for here. We still have the other one to solve. Cool, let's jump to this one here. So real quick here, if this was a negative answer, Your angle measurement will still be the same as a reference angle, but you would have been only looking in quadrants 2 and 3. Are we good? When you punch it into your calculator, you still would have punched it in as a positive number. We good? So when you punch into calculator, it's always a positive number you punch in, because you just want the reference angle in quadrant 1, and then you figure out what it's going to be in the other ones. Okay, this one here, punch this into your calculator, -1 minus root 3 divided by 2. And approximately? -1.366. Perfect, okay. So a few things here. If you notice something, you would already know the answer already. If you didn't, you still would have went like this. You would have went theta hat is equal to cosine inverse of, and always use the positive value here. So can you punch in, oh, how do we do that in a calculator, huh? How do we do that in a calculator? So -1 minus the square root of 3 over 2. Oof. Look at that. Missed a parenthesis and it's all wrong. Can't believe that. 2 parentheses. Never mind. Going too fast. How about that? Yeah, I just need one in the beginning, huh? So insert a parenthesis. Love it. Now I love it. Okay. I wonder if I can do this. I never did. Let's see. So if I go negative of my answer. That's cool. Let's see. Yes, love it. Okay. So I changed it to a positive because I can only plug in positive values into the calculator to get my reference angle. So to get my theta hat value, I do this, I do this. Now that's the answer.
So you do the answer for positive one.
Uh-huh. Because you want to get the reference angle in quadrant 1. That's what you want. And then you can do the rest of it by.
Error domain.
Oh, bummer. Yeah. Shucks. Talk to me. Why do you think there's an error domain? I'll sing Jeopardy again. Da, 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 da.
Isn't it because it's bigger than 1?
It is, absolutely. You guys ready? It's bigger than 1. Not possible. Impossible. So we go back over here. And we say this little guy is a fat 0 with a slash through it. Love it. Okay, so then I only have 2 answers here. Got that one and that one from the first one we did this one. So that's perfect. B. It is 68.5 degrees and 291.5 degrees. Are we good there? Cool. And then part A, 68.5 degrees plus 360 degrees K. 291.5 degrees plus 360 degrees K. K is an integer. And I'm not sure, I think the back of the book does say K is an integer each time for every single one of those answers. You can put them as the end of all of them. Okay, are we good there with the calculator stuff? Two more? Yeah, I think we have time for 2 more. Sorry, I see a few people writing stuff down, so I'll wait a little bit. Go for it. Again, tell me if I'm going too fast or you need more time. And if you want to put maybe some notes in for your notes, just kind of put like this and just put positive. And kind of just to remind you, you want to put in a positive number into your value here. Okay, that's probably the most difficult one here for 6.1, right over here. So if you got that one, you did good. All right, let's go with two more. This one is something called horizontal translation. So notice inside the value itself, you have a plus 50 degrees. You have all degree solutions, so we don't need to do a and a b part. Just give me all of them. All right. So do you guys remember? Do you guys remember summation rules for science for signs? Remember that, or you guys did that? Yeah, so it was like what, sine of a plus cosine b, right? Plus cosine a, sine of b. Don't do that one, because this is more simple. If you expand it out to the summation rule, now you have sines and cosines, and now you're stuck because of it. So the easiest way we figure out how to do this one is you have a trig function all by itself, set equal to something. Let's take a look at some angle values. They give me sine of being root 3 over 2. Anybody give me those? Yeah, I'm looking for what? I'm looking for the y value being root 3 over 2. And then over here, a y value being root 3 over 2. Anybody? 60 degrees, maybe? I think 60 degrees, is that right? This one right over here? Because this cosine would be 1/2. And there's two answers here, so let's do this here. So I'm going to say a plus 50 degrees is equal to 60 degrees. Then we have a plus 50 degrees is equal to, and I need this guy here now. Did this one, I need this one. I don't know. Let's see if 60 degrees is the answer, also a reference angle for quadrant 2. I just need, I guess, 60 degrees shy of 180. Is that right? 120 good? Perfect. This one, I like this one, because then what I can do is just subtract 50 from both sides to give me the a value. So subtract 50 degrees gets me a is equal to, looks like 10, is that right? 10 degrees? Over here, 50 degrees. I got an a value of 70 degrees now. That's cool. Think I'm good. So here's my answer. My answer for a is that all of them would be 10 degrees plus 360 degrees K. 70 degrees plus 360 degrees K, where K is an integer. And I'm not sure, some textbooks, some trig books, what they do is they just put a comma and they put K as an integer, right? Some of them say, they write it out where, I'll actually put in the word where K is a integer. Okay, we jam, now we're okay with 11 now. And one for you guys. Look at that. All right, very similar to the previous one. So let you guys at least start it. How about this? Try it yourself just a little bit. you're gonna have to deal with fractions and radian measurement here. I think you guys can handle it here. Give you guys a minute. How about this? Try a minute, try it yourself. Your angle measurements, let's see, it's a -1/2. It should end up in quadrants 3 and 4, right? When you guys do it. All right, can't stand it any longer. Got to start it. So anybody help me out here? Quadrant 2 and 3. What is the angle measurement in radians that would produce a -1/2? This guy would be -3/2, comma, -1/2. So this it's the small angle, right? The small angle is pi/6. So I'm thinking since you're going past 180, it has to be. So a minus pi/6 is equal to 7 pi/6. Perfect. A minus pi/6 is equal to, and then I got this one here again. It's just pi/6 shy of 2 pi. I'm going to go with 11 pi/6. So if you kind of need to do the math behind it here, it'd be 2 pi minus pi/6. Common denominator would be a 6. This then translates into 12 pi/6 minus 1 makes 11 pi/6. Oh, not too fun. That means I have to add this right here. Oh boy. I need a common denominator here. I think it's 18, isn't it 18? Do you guys remember doing this like all the way in grade school? Remember how you used to like do fractions when you're moving fractions away on the other side? I still remember that. Like you had to get common.
I remember that is the thing that happened.
Uh-huh.
It's possible that I once did it.
Okay, so I think 18 is the common denominator. And see, 3 times 6 is 18, so that means 21 pi. This guy's what, multiplied by 2, so 2 times pi is 2 pi. Added together gives me, man, 23 pi over 18. Perfect. Okay, other side, the same. Go for it. Eighteen. Let's see, that's gonna be that's gonna be. Oh wow, okay. This would be 33 pi. Yep, 30. Okay, here it is, 23 pi over 18 plus, what is it, 2 pi k? And then the 35 pi over 18 plus 2 pi k. K is an integer. Are we good? Okay, finally we're done with 6.1. So let's go with it here. Bring me homework questions on Wednesday. We'll do that as the beginning part. And we'll go with 6.2, or at least start with 6.2 on Wednesday. All right, enjoy the rest of your day and enjoy the non-sunny day today.
Yeah, I know,
But
it's not sunny or Sunday, actually. I wish it
Yeah, I was
was.
confused.
It's not Sunday, actually.
Unless if